Thank you very much, Ronnie. That was a very kind, generous introduction. And thank you all very much for coming, especially those of you that have traveled from afar to be here tonight. It's a really great pleasure. I'm overwhelmed that there are all these people. I didn't expect so many people. I said to the people, don't put more than 40 chairs, no one is going to come. So I'm really surprised that you all came. Thank you so much for coming. And it's really a great pleasure to see so many faces of very good colleagues and friends and past and present students and my husband and everyone else, really. Thank you very much. Now, giving an inaugural lecture is always a daunting task, especially for a philosopher, because there are so many illustrious precedents in the field. And just to put my cards on the table, I mean, the name has already come up. One of the most famous precedents is Immanuel Kant, one of my philosophical heroes, who in 1770 gave his inaugural dissertation. Now, that inaugural dissertation marks a landmark in Kant's academic career because, first of all, it marks the beginning of a journey of Kant to what is known as transcendental idealism, so anticipates some of his mature view about space and time as forms of intuition. But also it marks what has become known as Kant's silent decade. So for 10 years, he didn't publish anything. That was it. So I want to reassure the head of school, the head of college, that I'm not going to enter into any silent decade, especially with ref approaching fast. And I hope I'm not going to end up into transcendental idealism either. So what I want to do really tonight, what I want to take this opportunity for is to celebrate my field, which is the history and philosophy of science. And why I think that this field matters. It matters to philosophy, it matters to science, and it matters to society in the times we are living. And I really want to celebrate my field by attending to three main tasks tonight. So I want to start with some recent facts. Then I want to present a philosophical problem, and finally canvass a possible solution to the problem. So let's start with some recent facts. We live in strange and difficult times where the values of science and scientific inquiries have dangerously been called into question in prominent quarters and journal headlines. The importance and reliability of science in establishing the evidence relevant to specific domains of inquiry has repeatedly been questioned. The consequences of this systematic attempt at spreading mistrust in science among the public are under everyone's eyes. From climate change denial to anti-vaccine movements, just to mention a couple of prominent recent examples. And the recent March for Science that took place about 2 months ago is testimony to the ongoing challenges that science and scientists face in our society. Now, leaving here aside the political motivations behind this trend, today I want to discuss a topic that is dear to me and has received increasing attention in contemporary philosophy of science, namely scientific pluralism. I think getting a better understanding of what scientific pluralism is, of its historical motivation and philosophical consequences, is really all the more important to set the record straight on the importance of pluralism in science, but it's also very important to rectify the tangible risk of misrepresenting pluralism, the tangible risk that we live in our time of waiving scientific pluralism as an excuse for politically motivated, controversial research agendas. So what often seems to be acting, to the eyes of the public at least, as a pretext for this politically motivated anti-science trend is the notion of expert disagreement. When two or more experts disagree on the same evidence for or against something, say evidence for or against the cause of climate change, or evidence for or against the benefits of vaccination, evidence for or against economic growth, and so forth. Now, expert disagreement is often waived as a false pretext for some no better qualified kind of pluralism that would seem to suggest or imply to the eyes of the public that debates on the cause of climate change or debates on the benefits of vaccinating children should not be taken as a foregone conclusion established on solid and overwhelming evidence. Now, the expert may disagree on the interpretation of given statistical data used to make economic forecasts, climate change forecasts, or else, is neither surprising nor a reason for public mistrust in science. It's a distinctive feature of scientific knowledge, precisely its being open for debate and discussion, its ability to scrutinize the evidence, pro or against a given conclusion. Scientific knowledge is distinctively anti-dogmatic, open-ended, critical inquiry with the ability to constantly revise and, if necessary, reject previously accepted conclusion on a given topic as more compelling evidence, and I stress evidence, comes to the fore. So to defend expert disagreement, which in itself is a positive, distinctive, healthy feature of scientific inquiry and of how science progresses over time, against the risk of being misconstrued and misinterpreted in public discourse, one needs to understand and carefully assess what's really at stake in pluralism about science. And scientific pluralism is my topic today. So let me then start with presenting scientific pluralism, some of its historical motivations, and the many varieties it comes with in contemporary philosophy of science. Scientific pluralism has been part of our philosophical discourse on science since really the 1960s. The American philosopher Ron Giere has given an illuminating characterization of the historical background against which scientific pluralism and more in general discussions about the role of science in society have emerged. So this is what he says. He says, widespread serious questions about the nature of scientific knowledge itself began to be raised in the 1960s and 1970s. During this period, many who grew up after World War II found themselves horrified by the use of B-52 and other high-powered military technology against Vietnamese peasants riding bicycles and armed with little powerful than AK-47. Around the same time, it became clear that modern industries, in particular agricultural technologies, were degrading the environment in many ways. Additionally, many women began to regard some household technology as more enslaving than liberating. Some people whose professional attitude were formed in this period became university professors. And a few of these focused their attention on the sciences, not as scientists themselves, but as critics of science. Not surprisingly, many of these critics found their ways into the humanities and social sciences, such as history, philosophy, sociology, literature, and eventually cultural studies. End of quote. So scientific pluralism, according to Giere, has emerged against this cultural and historical backdrop of the 1960s, 70s, has emerged as an intellectual reaction against what many perceived as the enslaving power of science and technology. It emerged in political and social contexts that wanted to give voices to minorities and marginalized communities against what was perceived as scientific orthodoxy. A typical example is also standpoint theory in epistemology, where the point of view or perspective of the powerless and socially disadvantaged groups, be it the working class or women or ethnic minorities, is singled out as epistemically privileged. So there is nothing in the historical origin and historical motivation for scientific pluralism that suggests an anti-science attitude in and of itself. And if anything, scientific pluralism embeds the open-ended, anti-dogmatic stance that is distinctive of science and scientific inquiry. Now, while the historical and social and intellectual motivation for the emergence of scientific pluralism in the 1960s, 70s, I think are clear, what is exactly at stake in advocating scientific pluralism today is far less clear. Scientific pluralism is usually understood as opposite to scientific monism, which is the view that says that science aims to establish a single, unique, comprehensive account of the natural and social world. Now, while so much is clear and is shared by anyone who calls herself a pluralist, What the position exactly amounts to, and whether or not it might be compatible with realism in science, namely with the view that science aims to give us a true story about the world, has invited a more nuanced answer. So what I want to do is to give you a list, which is a non-exhaustive list of some varieties of scientific realism and scientific pluralism, that have been defended and championed in recent times in the philosophy of science literature. So here is the first variety. It's called epistemic pluralism, and contends that we should be pluralist at the level of theories and models in science, although this pluralism is purely at the level of theories and models and doesn't translate into pluralism about ontology or about entities. So Helen Longino, for example, has argued that to successfully explain some aspects of human behavior, and she's been looking at aggressive behavior, it's necessary to abandon the presumption that there is one single correct approach to studying human behavior, and we should instead embrace a plurality of points of view. So, for example, in her case study, behavior genetics, social environmental approach, neurobiology, and developmental systems are all important in the explanation of aggressive behavior. Although each approach is characterized by distinctive questions, methods, and assumptions, and although each method differ in identifying the causes of aggressive behavior, at the same time, all the approaches are needed because they mutually constitute and reinforce each other. Here's another variety of pluralism that takes the name of ontological pluralism. Ontological pluralism defends the view that we should be pluralists not just about theories and models, but also about the ontology of the world, about the number of entities that populate the natural and social world. So, for example, a sophisticated ontological pluralist, like Anjan Chakravarti in my picture over there, might hold the realist view that while the fundamental ontology of the world consists of properties, so there's a fundamental ontology of, say, particles' mass, particles' electric charge or spin, and so forth, the way in which those properties are clustered together to form what philosophers call the kinds or natural kinds, in a way varies with the different scientific theories. So you can track the history of the electron from J.J. Thomson working with cathode rays to Dirac to contemporary quantum electrodynamics, and you can see how our images of the electrons have changed over time, how we have clustered and reclustered those fundamental properties in different images, for example. Those are what Anjan Chakravarti called the sociable properties in his account of ontological pluralism. Here's another variety of pluralism, explanatory pluralism. So Carla Fair, for example, defends explanatory pluralism as a way of describing the facts that more than one explanation is required to account for some phenomena. So in her case study is the evolution of sex and how we explain the evolution of sex, and why we need multiple account for it, account that cannot be integrated with one another without loss of content. So in her case studies, there are the Red Queen explanation. They argue that sex is beneficial for species to adapt and survive to a constantly changing environment. There is the Muller-Ratchet explanation. They argue that sex is important to recover genotypes, and the DNA repair explanation that maintains that sex is important to repair genome damage. But scientific pluralism is not just a descriptive of scientific practice. Scientific pluralism can also have a normative dimension. So here's another variety of pluralism. Ha-Seok Chang active normative pluralism as the doctrine of advocating the cultivation of multiple systems of practices in any given field of inquiry, where by system of practice, Ha-Seok means a coherent and interacting set of epistemic activities performed with a view to achieve certain aims. And for example, Ha-Seok uses this approach to discuss the history of the chemical revolution at the end of the 18th century and the emergence of Lavoisier oxygen theory over the rival phlogiston theory. Pluralism can be integrative. in searching for context-sensitive ways in which multi-level, multi-component causal factors can be integrated into an explanation of given target systems. So I'm thinking here of Sandra Mitchell, integrative pluralism in complex system biology, where she has advocated the view that we need to integrate multiple causal factors in the explanation of protein folding, for example. But pluralism can also be non-integrative. So here is John Dupre's so-called promiscuous realism as a typical example of non-integrative pluralism, where we're looking at the plurality of taxonomic classifications available for the same entities as a way of responding to the research interests of different communities and different epistemic agents. So if you ask a botanist what counts as a lily, you will get a different answer than if you ask a chef or if you ask a gardener. So the way we classify in taxonomy the same objects varies and depends on the research interests of different communities. Now, this is just to give you an idea of the number of varieties of pluralism that have been defended and championed in philosophy of science really in the past 20 years or so. So one may wonder whether there is really anything like a common ground behind scientific pluralism. And Kellert, Longino, and Waters have given a positive answer to this question. They have identified what they call the pluralist stance, where the pluralist stance, they argue, is a minimally empirical motivated commitment to acknowledge that, quote, there are kinds of situations produced by the interaction of factors, each of which may be representable. I'm underlining in red representable because I'm going to go back to this issue in a second, in a model or a theory, but not all of which are representable in the same model or theory. A more complete representation of some phenomena requires multiple accounts, which cannot be integrated with one another without loss of content. So the pluralist stance admits that, quote, if two models distort some of the same aspects, they might distort these aspects in different ways, giving rise to inconsistencies. And this is just one kind of situation in which a plurality of inconsistent approaches might be defended, end of quote. So the pluralist stance emerges as an empirically motivated, non-integrative stance that is also inconsistency friendly. Okay, leaves room for inconsistent approaches in science. I come now to the philosophical problem that I announced at the beginning of this talk. Well, one of the problems, as I see it, with scientific pluralism today is a certain way of depicting the view as inconsistency friendly and representational at the same time. Now, Kellert, Longino, and Waters, for example, are clear about the pluralist stance entailing an inconsistency-friendly account of how science works. They say, quote, we don't assume that the plurality of accounts should be consistent. We don't assume that all the truths from one accepted account must be translatable into truths of another accepted account, end of quote. The pluralist stance thus seems to entail an inconsistency-friendly account of how science works because it acknowledges that given the primarily representational role of models in science, when there are situations requiring the use of a plurality of models for a given phenomenon, each of these different models might accurately represent some aspects of the phenomenon at the cost of blurring or distorting other aspects which are well represented by other models. And the risk with this pluralist stance, as I see it, is that science becomes like a Tower of Babel, with a plurality of models speaking different representational languages, different representational idioms, so to speak, for the same object, the same target system, and truths cashed out in one representational idiom may not be translatable into truths cashed out in another representational idiom. So to give you an example of what I'm talking about here, let's discuss an example taken from atomic physics. It's an example that Margie Morrison discusses in a paper in Studies in History and Philosophy of Science, also in a chapter in her latest book. So in nuclear physics, there are 4 inconsistent families of models for the atomic nucleus. The atomic nucleus is accurately represented by quantum chromodynamics as consisting of hadrons, protons, and neutrons, each of which in turn consists of color quarks. So you have, find my pointer. Yeah, you have, can't really see my pointer anyway. you have the three quarks, the image which is on the far right, the UDD quarks inside each of the component of the atomic nucleus. So each proton, each neutron will be made by a triplet, a different kind of triplets of quarks. But if the phenomenon under studies is, for example, chemical valence or bonds among atoms, then we tend to use a different kind of model, which is the one at the bottom right corner, which is the shell model of the atom. So we think of the atomic nucleus as consisting of a series of shells where protons and neutrons sit according to the Pauli's principle. If the phenomenon under study is nuclear fission, then the liquid drum model is the model that best represents the atomic nucleus, and here is somehow a kind of graphic representation of what the liquid drum model tells you about the nucleus being a drop of incompressible nuclear fluid, is the image at the very bottom. And finally, if we're interested in studying radioactivity and light nuclei and nucleosynthesis, then the cluster model, the one at the center, is the one that best describes the nucleus. So what is to be said about this plurality of models? And where does the pluralist stance leave us with them? Now, if we take model to be primarily representational, really in the sense of mirroring or fact-stating the target system, stuff about the target system, it comes as no surprise that the pluralist stance entails some kind of metaphysical inconsistency. Each model of the atomic nucleus seems to accurately represent the same target system by stating different facts about the atomic nucleus and how it behaves. So it's a bunch of quarks exchanging gluons, or it's a molecular cluster similar to a resonance. It's a drop of incompressible nuclear fluid. It's a concentric bunch of shells where nucleons are distributed according to specific rules. Given the emphasis given to the representational role of models, understood as one-to-one mapping between the model and salient aspects of the target system, the pluralist stance seems to have the unwelcome consequence of opening the door to some kind of metaphysical inconsistency. This charge of metaphysical inconsistency worries me as a philosopher of science, and in recent times I've been thinking of ways of tackling this charge of metaphysical inconsistency, which arises also in a particular version of pluralism that I'm most interested in, namely the kind of pluralism which is inherent in a philosophical position called perspectivism. So what is scientific perspectivism? Scientific perspectivism is a philosophical view that has a long-standing pedigree, really back to Immanuel Kant, which I mentioned at the beginning of my talk, and really Kant's idea that our scientific knowledge is always from a specific vantage point. In recent time, the American philosopher of science, Giere, that I've already mentioned at the beginning of this talk, have been advocating a view called scientific perspectivism as a way of rediscovering this broadly Kantian idea that our scientific knowledge of nature is always situated and perspectival, is always from a specific vantage point. So perspectivism is really a reaction against the sort of God's eye view that claimed that it's possible for us to achieve a monist, objective knowledge of nature. Instead, according to Giere, the only claim we are justified to accept are claims of the form, according to this highly confirmed theory or reliable instrument, the world seems to be roughly such and such. Hence, most of the discussion surrounding perspectivism has focused on the role of models in science. And key to Giere's argument is really the idea that a scientific perspective is nothing but a hierarchy of models. So if you ask me, what is a scientific perspective? Think of it as a family of models or as a hierarchy of models. So that's the way he thinks about a scientific perspective. He talks about the Newtonian perspective, the Maxwellian perspective, the Einsteinian perspective. And the idea is we start with principles at the top and a series of initial conditions. Then we produce models, what Giere called representational models. So for example, I can use Newton's laws to build a model of the pendulum, and I use that model as a representational model that fit or matches models of the data. And that's how science works. Building models, they are representational model taken from high-level theory and matching models of the data that are somehow coming from the world. So there's the world and principle, and they meet halfway via specific hypothesis and generalization, but the key role is played by representational models. So perspectivism embeds a form of scientific pluralism because key to perspectivism is the idea that there are multiple perspectives on the same target system, and different perspectives are at play both synchronically, like in the example of the different models of the atomic nucleus that I just gave, or diachronically, if we look at the history of science and how, as I said, the Copernican perspective replaced the Ptolemaic perspective, or how the Einsteinian perspective replaced the Newtonian perspective, and so forth. Now, this emphasis on modeling practices has also raised pressing questions for perspectivism as an interesting and viable philosophical position in between realism and relativism. And this is really the philosophical problem that I want to address in the remaining of this lecture. How should we treat the pluralism that seems endemic in modeling practices? And is scientific perspectivism the right way to tackle this kind of pluralism? Or is there a risk, as some critics have argued, that this form of perspectival pluralism is itself metaphysically inconsistent? A worry that looms at large in the philosophical discussion is that by embracing pluralism and rejecting monism, one is effectively not just rejecting the idea that there is a single, unique, privileged account of nature, but also the idea that there might be a fact of the matter about the atomic nucleus. Does perspectival pluralism amount to a denial of the realist notion of truth? Does it amount to the idea that there are different truths about the same object that may well be inconsistent with one another? And if so, how can perspectival pluralism distance itself from what philosophers called alethic relativism, so relativism about truth? The view that truth is relativized somehow, or worse, does perspectival pluralism open the door to some form of fact constructivism in claiming that different models deliver a plurality of alternative facts about the very same objects? So the problem for a defender of perspectivism is to be able to walk the line between pluralism on one end and the risk of fact constructivism and alethic relativism on the other end. If pluralism has historically been a beacon for scientific tolerance, open-ended inquiry, and the rediscovery of marginalized voices, the tangible risk in our time is that in the wrong hands, pluralism might be misinterpreted as a false pretext to marshal a campaign against the very values of science and scientific inquiry in our society. This is the problem, and in the rest of my lecture, I want to discuss a possible solution to this problem. So I'm moving to the third and final part of this lecture. So I promised to attend to three tasks, really. I wanted to start with some recent facts. I moved on to present a philosophical problem about pluralism in science. And what I want to do in the remaining of my lecture is to foreshadow a possible way forward in addressing the problem about scientific pluralism. And I apologize in advance, it's not a research paper, it's supposed to be a public lecture, so I'm going to be very kind of vague and hand-waving in what follows. What goes wrong in the tempting association of perspectival pluralism with either alethic relativism or fact constructivism? My diagnosis is that what goes wrong is a conflation of two distinct notions, the notion of objectivity and the notion of truth. Recall that the primary task of scientific pluralism is a rejection of monism, of the view that there is a single, unique, privileged account of the world, natural world, social world, depending on what your field of inquiry is. Now, rejecting the idea that there is such a unique objective privilege from nowhere, as philosophers like to say, to use Nagel's expression, account, is not one and the same as rejecting the idea that there might be a true account of nature. And we need to be really careful in not conflating those two. Truth has long been regarded as a stronghold of another philosophical position that I mentioned in passing, I'm going to say a little bit more about it now, called the scientific realism. And this is the view that says that science aims to give us in its theories a literally true story of the way the world is. Now, a literally true story means that we should take scientific theories at face value. If a theory talks about electrons, we should understand the theoretical terms of the theory as referring to electrons. And we should also take what the theory says about those entities as corresponding to the way things are in nature. So if physics tells us that electrons have negative electric charge, to be a scientific realist means to believe that it is true that electrons have negative electric charge. Namely, to be a scientific realist is to believe that there are mind-independent states of affairs about the electrons that make it true that electrons have negative electric charge. Now, there is a widespread tendency to conflate objectivity with truth, and the confusion originates from the fact that in scientific realism, the two tend to go together. So to be a scientific realist usually means to believe that scientific theories are approximately true in the aforementioned sense of corresponding to mind-independent states of affairs. And it also means to believe that such corresponding amount to a one-to-one mapping between what the theory or the model says and the mind-independent states of affairs. It is this one-to-one mapping that is captured by the aforementioned idea that scientific models accurately represent salient aspects of the target system. That's the role of representation in science and the representational role of model. If there is more than one model that can legitimately claim to accurately represent a salient aspect of the target system, as is the case with pluralism, then the problem of metaphysical inconsistency seems to arise. So in other words, according to scientific realism, the true model is the one that is regarded as offering an accurate, de-rare representation of relevant features of the target system. And this means to establish, as I said, a one-to-one mapping between features of the model and mind-independent states of affairs, where those mind-independent states of affairs are taken as embedding some important, essential, defining properties of particulars, for example, the essential property of having negative charge for the electrons, or the essential property of being a fermion for protons. So as such, mind-independent states of affairs act as ontological grounds that make the knowledge claims delivered by the model true. Now, in my current ERC project, I've been tackling precisely this problem with an eye to reconciling realism about science with perspectival pluralism as an integrative and not inconsistency-friendly account of pluralism. This is what the term perspectival realism is meant to capture. I want to be realist about science. I care about science, and I care about the truth in science. But I want to be a pluralist as well. It's a fact about science that we should be pluralist. So how to reconcile the two of them, okay? So the underlying idea behind the project and my current research is that rejecting monism about science, embracing a suitable version of perspectival pluralism, is compatible with the realist attitude towards science. Perspectival pluralism need not land us into metaphysical inconsistency or anti-realism. It doesn't entail giving up on the pursuit of truth in scientific inquiry. And more to the point, perspectival pluralism doesn't open the door to either alethic relativism or fact constructivism. And to catch a glimpse as to why this is the case, let's go back to our example about the four inconsistent model of the atomic nucleus. Now, the truth about the atomic nucleus consisting of colored quarks emitting gluons that carry the strong force is actually compatible with the truth about the nucleons behaving like a liquid drop in suitable conditions where the nuclear force between nucleons is a residual effect of the strong force. And this is in turn compatible with the truth that the binding energy of each nucleon is a function of some so-called magic numbers, as physicists call them, 28, 20, 28, governed by the Pauli principle in the nuclear shell model. And this is in turn compatible with the truth that the binding energy of nucleons is maximal for nuclei with even and equal number of protons and neutrons, as the cluster model says. So the idea that a plurality of model may lead to inconsistent truths at a closer look appear to be an artifact of a certain philosophical way of thinking about models and pluralism. It's an artifact of a certain way of thinking of models as offering primarily an accurate, rare representation of the target system or suitable portions of it, in the sense that I've clarified as a one-to-one mapping onto different and inconsistent states of affairs with inconsistent essential property attribution to the same particulars. To reconcile then pluralism with realism, I think there is some interesting work that perspectival realism has to do. First, it has to get clear on some important distinctions, such as the distinction between objectivity and truth, and shed light on the sources of the widespread conflation between these two notions. But it has also to unveil some powerful assumption that might be in place when the notion of objectivity and truth get conflated. For example, one such powerful assumption is the widely endorsed and never really questioned assumption that scientific model primarily represent in the sense of one-to-one mapping onto the target system or salient parts thereof. Another such powerful assumption is the idea that mind-independent states of affairs may act as ontological grounds, ascribing essential properties to particular for the truth or falsity of our knowledge claims. Now, as these very brief observations and remarks immediately reveal, no metaphysical inconsistency arises by using a plurality of model for the atomic nucleus as soon as we get rid of the representationalist assumption of the idea that a plurality of model offer inconsistent Giere representation of the same target system, but presumably mapping onto a plurality of inconsistent states of affairs. The problem with pluralism that I have outlined earlier turns out to be a philosophical artifact of a widespread and, in my view, ultimately misguided way of thinking about the representational role of scientific models. Noetic relativism or fact constructivism is entailed by perspectival pluralism once properly understood. I come now to the positive role and contribution that I think a historically and scientifically informed philosophy of science can make and should make to this ongoing debate about realism and pluralism in science. So I want to ask the question, what good is history and philosophy of science, since I said I was going to celebrate my own field? Well, philosophers of science occasionally receive really bad press from the scientists, and one of the worst one is Richard Feynman's famous quote that philosophy of science is about as useful to scientists as ornithology is to birds. I have some very good colleagues, physicists in the audience that are looking at me. I know they don't share the view. But anyway, for someone like myself who has always loved really philosophy of science and cares about the importance of the dialogue with scientists, Feynman's uncharitable verdict sounds like a death sentence on the entire profession. So what's the purpose of doing philosophy of science if scientists don't care about it? But with the years, I've come to realize that Feynman was simply wrong in his analogy. For ornithology is not meant to be useful, whatever useful might mean in this context, to birds. Ornithology is designed to tell narratives about birds, and after all, birds are not very good at telling narratives about themselves. And that's about how useful philosophy of science can be to science. It tells narratives about science and about what scientists do, but not necessarily with the goal of being useful to scientists. I'm sure that shoemaker, bus drivers, and builders are all more useful to scientists than philosophers can ever be to anyone else, including themselves. But that's not the point of Feynman's analogy, right? So the point is, okay, what good can philosophy of science be to science? I think there is a distinctive, beneficial role that philosophy of science can play and does play for science in clarifying and teasing out powerful hidden assumptions in scientific narratives, especially when those assumptions may dangerously play out in public discourse as part of an anti-science rhetoric. But there is more. Philosophy of science is also beneficial to science in a more substantial way. And I'm thinking here of how it can shed light on powerful and often overlooked heuristic role of models. So let me say something a little bit more detail about what I've been working on. For my ERC project, I've been looking very recently, for example, at the plurality of models used in contemporary high-energy physics as a way of exploring the space of possibilities for a new physics beyond the standard model. After the discovery of the Higgs boson in 2012, when the standard model in high-energy physics seemed to be finally confirmed, there are still wrinkles that remain that suggest to the eyes of many that we should look for a physics that goes beyond the standard model. One such wrinkle is called the naturalness problem. So why is it that the mass of the Higgs boson is such a low measured value, for example, how we can give an explanation of that. Another wrinkle is the search for dark matter that, according to cosmology, constitute 23% of all the matter of the universe. A further wrinkle is how to reconcile gravity with quantum mechanics. There are lots of wrinkles that suggest we should go beyond the standard model and look for physics beyond the standard model. So for my current project with my team, I visited CERN. I look at some of those modeling practices used in that context. And what's philosophically really fascinating about those modeling practices is how pluralism is an intrinsic aspect of the heuristic process. To search for new physics, if any such physics exists, a plurality of models has to be adopted. And let me give you just two brief examples of this pluralism in high-energy physics. So suppose we're interested in finding out possible particles that go beyond the standard model. Well, one possibility is what is called the supersymmetric particles, and the theory behind them has been the object of investigation for decades now. If supersymmetry is correct as a theory, in addition to quarks and leptons, we should introduce entire new classes of particles called squarks and leptons, whose masses and decay modes would need to be found experimentally, and that's what people have been doing at LHC. They've been trying to find, among other stuff, evidence for the existence of those objects. But how to go about looking for those objects? Well, a possible strategy consists in producing models of possible SUSY particles that attribute different mass values and different kinds of decay mode to these objects. So, for example, in this ATLAS collaboration of 2015, scientists adopt a specific method called the phenomenological minimal supersymmetric model. What they do is to sample the space of possibility for supersymmetric objects by reducing a very complex parameter space that has over 100 parameters to only 19 parameters and ascribing different numerical values to those 19 parameters. What you get as a result are what physicists call model points, and they get about 500 million model points that they then have to compare with experimental data coming from LHC, both at round 1 and at round 2. And what happens is those experiments are designed to trim down precisely this huge, complex space of possibility that scientists are trying to explore and map. So, for example, by using data coming from round 1 at 8 tera-electron volt, they're able to say that we should reduce the 500 million model point down to 310,000 model points. And by using round 2 at LHC, they're able to trim down the space of possibility even further. So what is interesting is that pluralism is an intrinsic part of the heuristic process of how we go about mapping the space of what might be the case, of what might be possible beyond standard model. And here is just an example of 4 different model points, so you can't really see because it's so fainted. But what each of those graph shows you is a possible supersymmetric particle scenarios. So all those different objects are different hypothetical SUSY particles. They have very different mass values. So for example, the Xeno, which is the first object, anyway, the first object just up there may have a value of 2,800 gigaelectron volt in this model, but a different value of 2,400 here, a different value of 4,000 over there. In some cases, it decays directly into these objects called the neutral linear. In other cases, it decays in a mediated way. If we think of models as having a representational function, this is a mess. This is a metaphysical inconsistency at its best. But what I've been trying to suggest all along is that we shouldn't think of models as having primarily this representational function, and we should think of them as having primarily a heuristic function, precisely the function of mapping into a bewildering complex space of possibility, which is the only way of actually going about looking for new physics in those contexts. And to give you another example, this is an example taken from a contour paper by Butterworth and Michael Kramers. What they do is to use a slightly different methodological strategy. So they're not endorsing SUSY, they're endorsing what is called the simplified models, which are very simple models stripped down to the basics. So we imagine a model that has a possible candidate for dark matter that's produced via a possible hypothetical Z prime boson. And also in this case, what they do is to produce a plurality of simplified models. What you have here in different colors, the red, the blue, all the other colors, a different simplified model that assign a different mass value to those hypothetical objects and compare those models with data points coming from ATLAS and from the CMS, which are the 2 main experiments at LHC, so as to produce those things, those beautiful objects, which are called the heat maps. And what the heat maps do is to show the exclusion region, areas in yellow that have been experimentally excluded. The data coming from the LHC excludes the possibility of having a Z prime boson decaying into this hypothetical particle, dark matter particle, with a certain confidence level, which is a different color. So yellow means it's been excluded with 1% confidence level, 100% confidence level. The area in black means the sensitivity of the LHC physics doesn't reach the area yet, so we don't have reliable data. And then there's all the spectrum in between, which is covered by the purple and so forth. So what good is then history and philosophy of science, going back to my question? Well, what I want to suggest is that we should consider perspectival pluralism as a form of modal pluralism, or pluralism about possibility, which is very important for exploring what might be the case. So it's very important for the purpose of scientific discovery and scientific inquiry. And I hope in the months and years to come to work more closely on this form of modal pluralism and how what might be physically conceivable can act as a guide to what is real. But I'm afraid this is going to be the topic of another paper. So there's an entire branch in philosophy called the epistemology of modality that might be brought to bear precisely on this issue, and that can in turn be illuminated by real case studies coming from LHC physics. And this is the positive, beneficial role that I see philosophy of science to play for science. Philosophy of science can shed light on crucial methodological aspects of scientific practice, illuminate how to go about making new scientific discoveries by, for example, clarifying how what is possible may act as a guide for what is real, by assessing the reliability of different ways of modeling what's possible, by exploring how experimental data gets selected to gradually refine what is possible and exclude some of those possibilities, by scrutinizing the role of statistical evidence and so forth. These are just a few examples of the task ahead for philosophers of science who are interested, as I am, in LHC physics, as an example of an area where I believe philosophy of science can be useful to science and to scientists. So to conclude my talk, I started with some recent facts that seems to suggest the public distrust in science, and with the problem concerning the role of pluralism for science. Easy and tantalizing as it might be to blame on pluralism the current attack to the values of science for our society, I hope I have shown how a more careful reassessment of scientific pluralism and of its beneficial role for scientific practice and scientific discovery suggests a very different image. Pluralism and realism can be made compatible if we understand the quest for pluralism not as denying truth or producing different facts. Pluralism, far from being a Tower of Babel where disagreement and inconsistency reign, is instead a key feature of how science progresses at any historical time and across the history of science. And so I'm coming to the end of my lecture, and I want to conclude by paying a homage to this wonderful city that hosts us and really to its intellectual heritage. And I want to conclude with two quotes from two great Scots whose work has really shaped the landscape of both physics and philosophies. So the first comes from James Clerk Maxwell. This is a statue in George Street I discovered from a recent documentary of the BBC. Apparently lots of people pass by. I've never heard of Maxwell, don't know who Maxwell is. It's one of the greatest scientists of all time, Edinburgh-born James Clerk Maxwell, and father of the electromagnetic theory. In the early 1860s, he famously published a so-called honeycomb model of the ether. You have a picture here, as an explanation of the phenomenon of electromagnetic induction that Hans Christian Ørsted in Denmark and Michael Faraday had discovered in the 1820s. So electromagnetic induction is basically the discovery that there is an important connection between electricity and magnetism. So it's a discovery that basically you can see a magnetic needle moving if there is an electric current passing in a nearby wire and the other way around. So it's one of the important defining moment of scientific history where the connection between electricity and magnetism was discovered. And in 1860, Maxwell was grappling with the problem of how to explain electromagnetic induction, so he came up with this idea. What if there is an ether? What if this ether consists of vortices, the little tiny hexagons, that move, their angular velocity produces a magnetic field of a certain strength, and by moving, they move also those little wheels, the Hadron wheels, and this is nothing but the electric displacement. This is how magnetism is related to electricity. Now, Maxwell accompanied his honeycomb model of the ether with the following quote. He said, well, the conception of a particle having its motion connected with that of a vortex by a perfect rolling contact may appear somewhat awkward. I don't bring it forward as a mode of connection existing in nature, or even as that which I would willingly assent to as an electrical hypothesis. It is, however, a mode of connection which is mechanically conceivable, and it serves to bring out the actual mechanical connections between the known electromagnetic phenomena, so that I venture to say that anyone who understands the provisional and temporary character of this hypothesis will find himself rather helped than hindered by it in his search after the true interpretation of the phenomena. Modeling what might be conceivable, mechanically conceivable in this case, could act as a guide to the true interpretation of phenomena, Maxwell says, even if the model is not meant to and should not be understood as representing accurately any real connection in nature, and not even as an electrical hypothesis, he says. 50 years before Maxwell ether model, another Edinburgh mathematician and philosopher, Dugald Stewart, whom our building is dedicated to and is also celebrated in the famous monument in Calton Hill, addressed the importance of having a criterion of truth. So he says, if no test or criterion of truth can be pointed out by universal consent, may not all those errors which Bacon has called idolatribus claim a right to admission among the incontrovertible axioms of science? And may not the popular cavils against the supposition of the Earth's motion, which so long obstructed the progress of the Copernican system, have been legitimately opposed as a reply to paramount authority to all the scientific reasoning by which it was supported? Against the risk of legitimizing what the philosopher Francis Bacon called the idols of the tribe, incorrect conclusion originating from our fallible human nature, Dugald Stewart reminds us of the importance of having a criterion of truth in science. And so it is for the advancement of science and the defense of pluralism, against the risk of being misinterpreted in the public sphere, that philosophers of science should stand up today for the future of our society as an open, tolerant, pluralist society, and also the answer to some pressing challenges that our planet faces today, depend also on how we, as philosophers of science, are able to engage with scientists and contribute to scientific narratives and public discourse about science, truth, and pluralism. Thank you.